Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This looks like something out of Algebra 2. Has to do with a piecewise function and then questions about continuity. You'll cover this in more depth in calculus. There are all these theorems that you can use for proving something is or is not continuous. But here we're just going to use common sense. And we're going to use a graph. So I put some graph paper underneath what we're doing, and hopefully we'll be able to get through this in one piece. Okay, so I want to just put a put an XY axis in here. Get that straightened out. Okay, and then I'll unfortunately neatness counts on this problem, so let's do our best here. Okay, and we're going to color code these pieces to make it easier to see, and then we'll just plot them. So we'll start with green, say. So, oops. Okay. Okay, so this will be the green. So negative 2x plus 1. So we know that it has an intercept of 1 and it has a slope of negative 2. So you could think of it as here, and then we're going to go down 2 over 1, down 2 over 1. So this would be the next point. And then down 2 over 1, this would be the next point. Oh, let's start again just to review. So you start at the y-intercept here, and then you use the slope down 2 over, y-intercept here, down 2 over 1, down 2 over 1. So that's where the graph is going to start, because it's only applies when x is greater than 2. So what that means is I have to use an open dot instead of a closed dot. Let's see, where do we start again? Up and then down 2 over 1, down 2 over 1. So it's going to be an open dot. And we know it's just going to continue downward. And so we'll just put in a couple more points here, down 2 over 1, down 2 over 1, down 2 over 1. It's just going to continue downward. And we're going to indicate that it does this infinitely by putting an arrow here. Okay, so that's our first equation. It's just a straight line with an intercept of plus 1. So if you went up 2 and over 1 and then 2 and over 1, you'd have an intercept of plus 1. Okay. Next one is a parabola opening down. So let's change colors here. Do another color. And when x is 0, y is 5. So once again, I'm starting with the y-intercept. I'm going to go up 5. 1, 2, 3, 4, 5. I know it's going through there. How about when x is 1? When x is 1, y is going to be what? It's going to be -4 plus 5, right? And x is 1. It's going to be 1 squared, which is 1, times -2. Ooh. Do that again. It's going to be -2 times 1 squared, so it's going to be -2 plus 5. So that's going to be 3 there. Okay, 1 comma 3 is the next one. 1 comma 1. 1, 2, 3. And we know it has to have a corresponding point like this because of the symmetry of the parabola. And we're going to need one more point here to finish it on the right-hand side. So let's calculate again. X equals 2. Y is going to be -8 plus 5, which is -3. So when x is 2, this is 4 times -2 is -8. Okay. So 2, -3, 1, 2, -3, 1, 2, 1, 2, 3. So it's going to go through this point here. So because this shares a point, you see, this point here, it's open for the green, but it's closed for the blue. Let me put the sister point over here. 1, 2. Okay, so now you can see what this is going to look like. Let's pay attention to the left-hand side. This is only defined up until -1. So this is it actually stops here, and it's actually an open circle because there's no equal sign here. So I have to go back and fix that open circle over there. At -1 when x is -1. So now this curve is, and we're going to ignore this point down here now, just get rid of that. So now the curve is going to look like this. And it's closed with respect to the blue, and it's open with respect to the green. And we have one more to do. So let's find another color. We'll use orange. And this is a line with an intercept of -5. So let's go find that. 1, 2, 3, 4, 5. There it is. And a slope of -4. So that means down 4 over 1. So 1, 2, 3, 4. That would be the next point because it's down 4, 2, 3, 4 over 1. And then we do the same thing here, over 1, up 1, 2, 3, 4. And then over 1, up 1, 2, 3, 4. Something like that. Looks like I went a little too far. This is only defined when x is less than or equal to -1. So that means it's because of the equal sign, it means it's going to have a dot here. And I want to double check this. When x is -2, this is 8 minus 4. Yeah, that's wrong, isn't it? Hold on a second. It's definitely -5, and then -1, -1, and then -2. 8 minus 5 is 3. So it's actually here. 1, 2, 3. Yeah, I'm sorry about that. Get rid of that guy. I'm going to redo this one. So over 1, 2, 3, 4. There we go. Okay, but I don't think we need that one. This is only defined when x is to the left of -1. So here it is. 1, 2, 3, 4 over 1, 1, 2, 3, 4. So what we don't need is the intercept, the y-intercept. So I'm just going to erase that. But the y-intercept is always a good place to start. I can't seem to erase the dot there. We'll just ignore it. And we know this is going to be filled. And you can see it doesn't quite go through the link up with the other part of the graph. And this just goes infinitely higher and higher as x gets more and more negative. Okay, so now we're ready to answer the question. You can see it's much easier to answer the question when you've got a graph in front of you. And obviously the color, I think, helps a lot. Okay, so we'll put our answers in another color. Come on now. Here we go, black. So there's the graph. So we did that one. State all points where f of x is discontinuous. Well, it's discontinuous when x is equal to -1. And this is called a jump. There's a jump here. You're following this. Let's say you're moving left to right. You're following this down. And then you have to make a jump. So whenever you have to make a jump like that, it's a point of discontinuity. For which of the points found in part A, I'm not sure what part A means, that's just the graph, but I think they mean above. They probably mean part B. For which of the points found in part B, I think, is the function right continuous, or no, they mean the whole graph, right continuous. So right continuous means as x approaches infinity. So it's continuous from -1 on, but you have to be careful. -1 to infinity, and it's continuous there. The -1 has to be a rounded bracket because it's an open circle, and infinity is always a rounded bracket. I'm not sure how the teacher wants this expressed, but right continuous, I believe when you're coming in from the right, you're continuous all the way out to here. If you're coming in from the right-hand side. And then let me erase this because it doesn't help anything. And then when you're coming in from the left side, obviously you're coming in from the left, and you're going to be, when you come in from the left, you're going to hit up against this orange line, and then you're going to slide down to here. So negative infinity this is from 1x is negative infinity to -1. It's continuous there as well. And I think that's what they mean by left and right continuous. And this should be a square bracket around the -1 because this dot is filled. And this is a less than or equal to because of the equal sign. That's a square bracket, and that's it. You just sort of have to be careful with it. There's a lot of detail. Do it one step at a time. Don't let it intimidate you. Just break it down into steps, and it's not that hard. Okay, so that's it for this problem. I hope this was helpful to you, and I'll see you again next time. Bye-bye.